Alright, today Academic Daddy will continue the class on gas questions, and today this is the part 2, question 4. Now the question goes like this. It say a 2.5 liter container holds 0.45 moles of neon gas. V equals to 2.5 liter. Holds 0.45 moles. You know that mole is amount of substance, so it's having 0.45 moles amount. And it's asking us what is the pressure. What is the pressure? So we don't know the pressure. What is the pressure inside the container? What is the pressure inside the container? Now the question we have give us temperature to be 315 Kelvin. Very good people. They already solved it for us. So they don't want us to stress converting from Celsius to Kelvin. So the 2.5 liter container holds 0.45 moles of neon gas. What is the pressure inside the container? T equals 315 Kelvin. So we've interpreted it and we have this. So making use of what we have, we now see that this is the same thing as PV equals to nRT. We have P as our subject of formula. We have that this will be divided by the coefficient of P, which is V. So this becomes P equals to nRT over V. P is equals to N here is 0.45 times R is a constant, always 0.0821 times T here is 315 given to us all over. Volume given to us is 2.5 and is in liter. That's good. That's what we need. We need it in liter. So when you do the mathematics, well, you do the punching, you know that this is the same thing as punch. You have that this is the same thing as giving you 11.6377 all over 2.5, and that gives us on division 4.6551 here. So it gives us 4.6551 here. So that's our answer for that. So let's move to the next question. Now the fifth question say find the total pressure of a gas containing 500 torr. Then 500 torr of nitrogen gas, then 200 torr of oxygen gas, then 50 torr of argon. Ag of Ag, I say argon, that should be silver. So this is, whenever you see a question is asking you to find the total pressure, know that what they are talking about is Dalton's law of partial pressure. Notice that most of the questions we've been solving so far are centered around ideal gas equation and Graham's law of effusion. And Graham's law of effusion, what is effusion? See what effusion is. See the spelling. Effusion, like this. Effusion. In some textbooks you see it as just one F. So what this means is the diffusion of gas through a hole. Diffusion of gas through a hole is called effusion. And you know that diffusion, I told you to think of it as dilution, movement of particles from region of higher concentration to region of diluted, or you say lower concentration. So when you see questions on two gases, then asking you for the density, molar mass, or the weight, no, it's Graham's law of effusion. When you see it's giving you everything and then asking you for one, no, it's PV equals nRT gas. Now when you see a question asking you for total pressure, no, it's a Dalton's law of partial pressure. Dalton's law of partial pressure, and it states that the individual sum of the pressures, or the partial pressures of a system, make up the total pressure. Dalton's law of partial pressure states that the individual sum of the pressures, or the partial pressures of a system, gives the total pressure, is the total pressure. So in that case, this becomes PT equals to 500 plus 200 plus 50, which is the same thing as total pressure to be 750. And since everything is in torr, that means this is 750 torr. So let's move to number 6. It says it takes number 6 it takes 5.12 seconds for a sample of krypton to effuse from one compartment into another at a constant temperature. Determine the time it takes for an equivalent sample of neon to do the same. Now, the summary of the Graham's law of effusion is that lighter gas travel faster than heavy gas. So the lighter you are, the faster you are. So that means that if you put a gas that has lesser molar mass, it will be the first gas because it will travel faster. It will be the M1. So for that reason, my quoting the law simply means that rates of diffusion of gases is inversely proportional to the molar masses apart, and this means that if you have a load and more load is added, it will take you more time to accomplish that load. So if you increase load, you increase time. So molar mass or concentration is directly proportional to time. So T1 for M1, they are facing. That means they are directly proportional. This one is inversely, the rate is inversely proportional. So since I know that, it simply means that whenever I'm not giving rate and I'm giving just time, I check for the molar mass of those elements using their arrangement in the periodic table. Then since I know that neon is number 10, atomic number 10, that means the molar mass will be 20, but this time is 20.18. Then krypton represented as Kr, its atomic mass is 83.798. So this one is natural by nature, it exists this way. So if I carry it now, that means the formula I'm going to use is just M2 over M1 equals to T2 over T1, because I was not giving weights. So this is my formula. This is the formula I'm making use of. So that I will now come and say the second gas is the heavy gas, the lighter gas is the first gas. So because, for example, if I spread perfume here, and for example I spray a perfume that is light, that has so much smell, you see that it will tend to travel faster than the one that is very heavy, that does not travel fast, or that has so much particles embedded in it. So when you are light, you tend to move faster compared to when something is heavy. So for that reason, if I spread a perfume that contains neon and a perfume that contains krypton, because krypton is heavy, it will take it time to travel compared to the way neon will move. So that means this is 83.798 all over 20.18 M1 first gas neon, second gas krypton equals to, so my T2 now given to me, since they gave me time for krypton, and krypton is the second mass, that means the time T2 is for time for second mass. So second mass, so T2 given to me, they gave me 5.12 seconds all over. T1 is what I don't know. That's what they say I should find. They say I should find the time it will take neon to do the same. So if I do the punching, this becomes 4.1525 equals to 5.12 seconds over T1. If you take the square roots, you have that this is 2.0378 equals to 5.12 seconds all over T1. Anything standing on this one is over 1. So cross multiply, you have this to be 2.30378 T1 is equals to 5.12 seconds. So divide both sides by the coefficient of T1. So T1 is going to be equals to 2.51 seconds. So notice it. Notice that it took krypton 5.12 seconds, but it took neon 2.51 seconds. It took neon lesser time to travel because it's a lesser gas. So this one is heavier. It took it more time, or it takes longer time to travel. So that's the 6th question solved. So look at it. He said it takes 5.12 seconds for a sample of krypton to diffuse from one compartment, that is to move from one hole, one opening, into another at a constant temperature. Determine the time it takes for an equivalent sample of neon to do the same. So this is our answer. So let's go to number 7, the 7th question. Alright, question 7 says an unknown gas has a rate of effusion that is 4 times. So we've seen effusion is Graham's law. Let me just write the formula. Rate of effusion of gases, or of two gases, is inversely proportional. Inversely means, for example, if I have something is inverse, it means, let's say I have A now, inversely proportional to B, it means like this 1 over B, which is the same thing as A equals to 1 over B. Maybe I introduce a constant K. So if that be the case, that means that if I have R1 here and it's inversely proportional to the molar mass, that means molar mass of R1 will be like this. And if I have R2 to be down here, that means its molar mass will be up here. So when you combine it, that's how we now get this. So note. So if I know that this is the same thing as M2 all over, it's M1. So he said an unknown gas is 4 times. So the unknown gas, let's say, is the first, is 4 times, okay, 4 times faster than oxygen gas. Okay, we know that it's oxygen gas. 4 times faster than oxygen gas. So let me say that oxygen gas in this case is 1 because it's 4 times faster than it. So let's just say it's the same thing as saying R1 4, R2 1. Somebody that's no book too much can decide to say that this thing mean R1 8, R2 4, because whichever way you do it, the unknown gas must be 4 times faster than the second gas, which we know, which is oxygen. So because we don't know the gas now, and it's taking the position of R1, and that is M1. So M1, the rate of M1 is R1, the rate of M2 is R2. So for that reason, it will come down here. We don't know it, so it's just M1 that we don't know. Then this one is O2, oxygen is given. So when you do this cross multiply, this is the same thing as 4 over 1 equals to oxygen gas. This is O2. The atomic mass of oxygen is 16, then times 2 molar mass, which will give us 32. That is 16 times 2, 32, all over M1. So take the square root, take the squares of both sides. So to cancel this square root, this and this will get out. So that this becomes 16 over 1 equals to 32 over M1. 32 over M1. So that this now becomes cross multiply, so that I have 16 M1 is equals to 32 times 1, which is 32. So this is the same thing as divide both sides by the coefficient of M1, which is 16. M1 is equals to 32 divided by 16, which is the same thing as 2. So M1 is 2. So if M1 is 2, let's check the option. So the molar mass of carbon 4 oxide, the molar mass is 12 plus 16 times 2, 44. It's not possible. Then this one is 12 plus 16, that is 22, then plus this 28. It's not possible. Helium we know is just hydrogen, helium. The helium atomic mass is 2, but is helium a gas? So helium atomic mass is 2, but is helium a gas that is to react with oxygen gas? So the answer is no. So come down here. Hydrogen is 1, but the molar mass is 2. So know the difference. The molar mass is what we are talking about. Helium atomic mass is 2, not in the case of its molar mass, but because it exists in such a way that it does not have this, you can say that the molar mass is also 2. So the right judgment to differentiate these two is simply that this is a gas known to react with oxygen to give us water. So neon, the atomic mass of neon is 10. So the correct answer here is D, option D. But I know that in exam they will never bring a situation where you have helium and hydrogen. This question was copied from a student, and that student, I don't know how she writes. So there's no place they will give you this and give you this, because if they give you this and give you this, it will put you into trouble. You want to pick any of these. So the answer is hydrogen gas. Thank you. Please subscribe.